Hey, Blue Raiders, let's talk some math. In this video, we're going to talk about absolute value and inequalities. So let me share my screen and we'll get going with a couple of questions. So first of all, let's take a look at absolute value. What's it mean? I think a really nice way to look at absolute value is to consider a number line. So let's see here. We've got a number line and 0 and 13. So thinking about absolute value as how far away the thing that you're taking the absolute value of is away from 0. So 13 is 13 away from 0. So the absolute value of 13 is 13. Same thing here. There's 0, negative 13. How far away is negative 13 from 0? Well, it's 13 away. So absolute value has to do with magnitude, like how big something is, and it doesn't really care about the direction to the left or to the right on the number line. It's just kind of just a straight up distance, a non-directional distance. So that's a nice way of thinking about absolute value. And it kind of gives us some meaning beyond just a rule of ignore the negative if it's negative or something like that. All right. Let's think about inequalities and absolute values. So this will give us something new. First of all, absolute value with equalities first. So what are the numbers, the values that I can put in for x that would give me an absolute value of 22? So I think we know that the absolute value of 22 equals 22. But just like we saw in the previous example, the absolute value of negative 22 is also equal to 22. So the answer here is x could equal 22, and it would make, if x is 22, then that statement will be true. And if x is negative 22, it would make the solution true as well. I guess a picture might get in the way there. So, or x is equal to negative 22. Okay, let's think about this option for the second one with absolute values and inequalities here. Notice, first of all, that this is what we call a strict inequality. So it's strictly less than, and it's not equal to 22. So if we put in a value of 22 in here for x, that's going to be equal to 22. And is that less than 22? And the answer is no. So like putting in x does not make this putting in x equals 22 does not make that inequality true. Think a value that we could put in for x is maybe 21, right? Absolute value of 21 is 21, and that is less than 22, check. So like this one's wrong, but this one checks out. So anything less than 22 will work, right? Like 21 and a half, 20, 19. We could even think of like, I don't know, if x was 5, like if x was 5, we would have absolute value of 5. So that's equal to 5, and that's less than 22. So that checks out. X equals 5 works. We can keep getting smaller. X is negative 10. So negative 10, the absolute value of that is 10, and that's less than 22. So that works. We could think, well, that always work. Can we just keep getting smaller and smaller and smaller, more and more negative? And I think we realize if we get all the way to negative 22, then that absolute value of negative 22 is 22, and that is not less than 22, right? So nope, that doesn't work. So it's kind of like we've got a boundary. In a situation like this, absolute value of something is less than a number. It's like we've got a boundary. We can go all the way from 22 works. Anything less than 22 works until you get to negative 22. So it's like the solutions are in between these two solutions. So we can think about this on a number line. Sorry, I should say the solutions are in between these two boundaries. So let's think about it on a number line. So here's 0, here's a positive 22, here's a negative 22. I think we just said that any number that's in between negative 22 and positive 22 for x will make this inequality true. So we're good to go. But we said that at the boundaries, it doesn't work. So I'm going to put an open circle here at negative 22 and positive 22, because those numbers don't make the solution true. But any number in between is good to go. So we can use interval notation to, some of you may have used interval notation before to say that x can be any number in between negative 22 and positive 22. Here's how we do it. Negative 22, comma, positive 22. And we use parentheses on both ends, kind of round brackets. And if we know that this is interval notation, then this is saying that x can be any number in between negative 22 to positive 22. So it could be like 1.79843. I can go all the way up to 21.999782. Any number up to a positive 22 and down to a negative 22 will work for a situation like this. What about this one? The absolute value of x has to be bigger than or equal to 22. So we could check again, does 22 work? So absolute value of 22, that's 22. Equal sign, that's equal to 22. And is that greater than or equal to 22? And the answer is yes, because greater than or equal, 22 equals 22. So we're good to go there. And we can think on the boundary cases again. So think around this boundary. If x is 23, 24, 25, or even 22.117 or something like that, anything bigger than 22 will work. So anything less than 22, so like x is 20, that doesn't work. 10, 0, negative 5, negative 10. But we realize that if x is a negative 22, then things start to work again, because the absolute value of negative 22 is 22, and that is greater than or equal to 22. And if we tried, I don't know, like negative 23, the absolute value of negative 23 is 23, and that is greater than or equal to 22, right? So any negative number that's smaller or equal to, smaller than or equal to 22 will work as well. So this helps us. I think, again, a number line is super helpful for thinking about this. So in this case, we said, okay, 0 is here and 22 is here and negative 22 is here. Any number that's smaller than negative 22 or bigger than positive 22 will work. And we said this time, though, the actual values of 22 and negative 22 work. So we'll put in a solid filled in dot here to represent that x could be equal to 22 or a negative 22. So if we're going to use interval notation here, we realize, oh, okay, this is like, we're going from like smallest it could be to the left is negative infinity, I guess, all the way up to negative 22, including negative 22. And on the right, the smallest it could be is a positive 22, and then it can go all the way to infinity. So the way we use interval notation to write that is to say negative infinity with a round bracket, because negative infinity isn't really a number that you can actually get to, so you can't include that. But we said you can go up to a negative 22 and include it. So we'll use square brackets to say the number can be 22. And we're going to put that interval together with the other interval of 22 or more. And mathematically, we call that a union when we put two sets together. So it's going to be a union with this other interval of 22 to infinity. Got to do a round bracket on infinity because it's not really a number that you actually ever get to. Just keep getting bigger and bigger and bigger. So that is thinking about absolute values with inequalities. So next, let's take a look at solving equations. Like, what if we don't just have absolute value of x, just a variable all by itself, but what if we have expression inside the absolute value sign? Really, the same idea holds, right? We can think about this expression as a variable, like just think about this as x, or well, since we're already using x, maybe we could just think about that expression as W or some other letter, something like that. But just think about it as a whole thing. So we know that this stuff inside could be equal to -22 or equal to +22. So this is like a situation where we have two solutions. 5x plus 7 equals 22, or 5x plus 7 equals -22. Okay, 5x plus 7 equals 22. We've got 5x is equal to, subtract 7 from both sides, we get 15. So x equals 3. Or if we subtract 7 from both sides, be careful with your math. We get 5x is equal to -29. I think 22 minus 7 is -22 minus 7 is -29. So that means x is equal to -29 over 5. Okay, so in this situation with equality, we get two possible answers for x. So there we have it. A little bit different. X could be 3, or this -29 over 5, which is like a little bit smaller, like a little bit to the left of -5. It's on the number line. Okay, now let's take a look at this. This one is the same situation as the previous, right? It's just what's inside the absolute value sign is an expression now, but we're going to have a situation that's kind of like this, right? So, and one way for us to, we solved two different inequalities to get to these numbers, 22 and -22, or I think actually we just reasoned there. But I'm going to show you a way that we could kind of do the algebra and not get lost in the reasoning to get our, like, the boundaries of our range here. So let's take a look at that. We know that, just like how we just saw on the number line, that here's how we're going to write it. -22 is less than or equal to 5x plus 7. What's inside the absolute value sign is less than or equal to 22. Right? We said what's inside the absolute value sign has to be between +22 and -22. So there we have it. We can treat this as like a, I don't know, like a 3-part inequality or something. But since this is a true inequality right now, this is the problem we're given, we can work with our algebra rules to solve it. So in this middle part, if we take away 7, then we need to take away 7 from the other parts, right? So we can begin to isolate our variables here. If we take away 7 from -22, we get -29. That's going to be less than or equal to 5x, and that's going to be less than or equal to 22 minus 7, which we already solved as 15. Okay, now, if we divide by 5, we get that -29 over 5 is less than or equal to x, which is less than or equal to 3. Okay, so that's our range for x. You need to be careful, and mention, and again, you may have experienced this in a math class before. When you divide in a situation like this with inequalities, dividing by a positive number is not a problem at all. But if you divide by a negative number in order to solve for the value of x, it changes the direction of the inequality. So that's just something to be aware of, that all of the inequalities change direction if you divide through by a negative when you're at this step solving for x. Okay, well, let's take a look then. Here, this is our solution. So let's think about it on the number line, and we could write it in interval notation. So here's our number line. X could be 3, or x could be -29 over 5. So here we've got a less than or equal to sign. So that means these points are filled in. And then x is between these two values. So here on our number line is showing the graph of the solution. Then we can also write this in interval notation, that x is between negative 29 over 5 and 3. And it includes the endpoints. So that's that square bracket there in between those two numbers. All right, great. That gives us this case. Finally, we're in this situation where what the absolute value of this expression is greater than 22. I think you probably have an idea that it's going to be a situation where we're going into the extremes, right? That either what's here is going to be bigger than 22, or what's in here is going to be less than a negative 22, just like we saw in the previous situation here. Right? What's inside the absolute value sign is going to be here or here. So let's go back and solve it. We've kind of already done the algebra, but let's go ahead and flush it all out. So 5x plus 7 could be greater than 22. That means 5x is going to be greater than, subtract 7 from both sides, 15. So x is going to be greater than 3, or 5x plus 7 is going to be less than negative 22. And so that means 5x is going to be less than negative 29. And x is going to be less than negative 29 over 5. Right. So the solution is either going to be x is greater than 3 or x is less than 29 over 5. So we can depict that on a graph, of course. 0 here, 3 here, and anything bigger than 3. And question, should we fill this in with an open or a closed circle? And I think you know it's open because this is strictly greater than, there's no greater than or equal to. So that's why we've got an open point here. That's open. And then at negative 29 over 5, that's going to be open there as well. And we will fill in this graph. Okay. So these are the values that will make our inequality true. And we can write this, we'll close it out by writing it in interval notation. So we could say negative infinity to negative 29 over 5, and use a round bracket there, regular parenthesis, because the endpoint is not included. And we're going to union that with 3 comma infinity. And there we have it. So that's a lot. We talked about absolute values, which can be confusing for folks, and inequalities, which also can be confusing for folks. So I hope this was useful for you, and you can go back and rewind and stop and rework some of these problems if you like. And I hope it was helpful, and we'll see you next time.